This is a short concept module on Newton's second law of motion. This is one of three of Newton's laws of motion that really underpin our understanding of how forces relate to movement. So Newton's second law can be defined as acceleration of an object as produced by a net force directly proportional to the magnitude of the net force in the same direction as the net force and inversely proportional to the mass of the object. So what this is really referring to is the relationship between force applied to an object, the mass of that object, and the subsequent acceleration seen by that interaction. It's also sort of outlining the linear relationship between force, mass, and acceleration interacting with that concept. Or we can define it using an equation here. So it's a fairly simple equation: force equals mass times acceleration. So simple, but tells us a lot of information about how the relationship exists between those. So if I double the mass of an object, or one object is double the mass of another, then I'm going to have to apply twice the force to give it the same acceleration. So what effect does Newton's second law of motion have on objects of different mass? Well, you can imagine maybe I have a maximum amount of force I can produce on a particular ball, and if I've got a really light ball like the tennis ball and a really heavy ball, you can tell that the one with larger mass is going to have a lower acceleration because it has a larger mass. So for the same force, greater mass means less acceleration. We can also think about it applying it in the way we apply force to throw a ball at different distances. So if I want to throw the ball twice as far, well, I'm probably going to need twice as much acceleration coming out of the hand, and therefore I'm going to apply twice as much force. So you can start to see that force is a really driving factor of how far we can manipulate a ball to go, with the interacting factor of mass there.